I hope you're ready to start building because we are going to have our first lesson where we're going to be using our model kit and we're going to be building hydrocarbons. And we're also going to learn what are hydrocarbons. First of all, your kit contains many of the most important elements of life like hydrogen, carbon, nitrogen, oxygen, sulfur, phosphorus, a few other elements. Right now in this particular section, we are just going to focus on hydrogen and carbon. Putting hydrogens and carbons together gives us a category of molecules called hydrocarbons. The most simple hydrocarbon is methane. So right now we're going to look at the structure of methane. It looks like methane has one central carbon and 4 hydrogens bonded to the carbon. What we're going to do is we're going to build this molecule. We're going to use the one-hole white hydrogen pieces, as we mentioned before. You're going to just trust me why we're using the one-hole hydrogen pieces for now. So again, what is a hydrocarbon? Hydrocarbons are molecules that are made of only hydrogen and carbon. The simplest hydrocarbon, of course, is the molecule that you are about to build, methane. Its formula is CH4. So this is the first very important lesson that we're going to learn. The lesson that we're going to learn is that carbons make 4 bonds. We're going to use all 4 of the holes in the black carbon piece, and we're going to put hydrogens in all 4 holes. Every carbon that you will see in this program makes 4 bonds. Every hydrogen that you see in this program will have 1 bond. And because of this, hydrocarbons, and in particular methane, will have a certain shape to them. That shape is called a tetrahedron. The shape that you're looking at here, it looks sort of like a pyramid when you look at it in 3D, but it has a special name. It's called a tetrahedron. So as you build the molecule, you are building your very own tetrahedron. Be sure to use the one-hole hydrogens for methane, and as I said before, we will learn eventually why we're using the one-hole hydrogens, but for now, just trust me, all the hydrocarbons in this lesson will be using the one-hole hydrogen. So what is methane? Why are we starting off the program with a methane molecule? Well, methane, besides being the basis for carbon-based life, methane is also what we use for heating and power plants. It's a fossil fuel. So if you turn on your gas stove, what comes out is methane gas, and when you light it, it gives off energy. We will be looking at that reaction in a later lesson, but methane is one of the most important molecules that human beings use, really, because it's used for energy. Now that you've built your methane molecule, we're going to build larger hydrocarbons. We know that methane is used for gas stoves and for power plants, but there are larger hydrocarbons. The next hydrocarbon that's bigger doesn't have just 1 carbon, it has 2 carbons. This molecule is called ethane. We are going to be working more with ethane in later units, but for now, I would love for you to attach another carbon to your first carbon. To do that, you'll have to unplug one of the hydrogens from the methane and install a carbon, and then add some more hydrogens. This molecule is not used as a fuel. We're going to learn about what it's used for, but it's actually very valuable in the plastic industry. So while it may make sense that we would burn ethane also, we actually don't use it because it's more valuable to us as a molecule to build plastic molecules. Ethane's formula is C2H6. This means it has 2 carbons and 6 hydrogens, which we can see in the structure. The next molecule in the hydrocarbon series is propane. Propane's formula is C3H8. So at any time you can pause the video and build these or extend the chain of carbons so you can see what it's like to have these molecules in your hand. What is propane? Well, propane is very famous as also a fossil fuel. And if you have a barbecue grill, this is what you are burning in your barbecue grill. It's also used to heat homes and other things, but this is another hydrocarbon. It's another fossil fuel. Continuing down our list, we have another longer hydrocarbon. This one has 4 carbons. The formula for butane is C4H10. And as you can see, it's kind of got a little bit of a caterpillar look to it. It's a little bit of a chain of carbons surrounded by little legs of hydrogens, if you want to look at it that way. That's a very common look for hydrocarbons. What is butane? Butane is also a fossil fuel. It's used in lighters. It's used to heat homes, another fossil fuel. These 4 hydrocarbons are super important. The names of them are very important. The names will come up in different places as we learn more about chemistry and biochemistry. So what I've done is I've created a mnemonic device to help you remember the names of these 4 hydrocarbons. We see methane, ethane, propane, and butane. If you take the first letters of these, we can spell out a funny little sentence. The sentence is, must eat peanut butter. So definitely work on memorizing these molecules. Just remember, must eat peanut butter. This represents hydrocarbons of 1, 2, 3, or 4 carbons in a chain. These names actually show up in other places throughout chemistry and biochemistry, so they are pretty important to memorize. They also show up in your flashcards, so you can print out that sheet from your workbook and drill yourself and remember what these molecules are called. Once you build these molecules, you should check their structures and make sure that you have assembled them correctly. One of the most important things to do is to remember to put hydrogens in your carbons. You do not ever leave carbons with empty spaces for bonds. You have to bond the hydrogens to the carbon. Remember, carbons make 4 bonds. So no matter how long your carbon chain is, you're always going to be adding hydrogens to it too. Now, at this point, you're probably wondering, Dr. Fried, are there longer hydrocarbons? Well, yes, of course there are. There are even longer hydrocarbons, and these are solvents and fuels. Solvents means that we use the molecule in a chemical reaction to dissolve other chemicals. So the first one, continuing in this series, is pentane. Pentane's formula is C5H12. It's a longer chain of carbons. It has 5 carbons, of course, and more hydrogens. The next is going to be hexane, C6H14, a longer chain. The next is heptane. Heptane is actually found in gasoline. It's a fuel molecule along with hexane, C7H16. And then the last one on this slide is octane, C8H18. Do you notice any patterns in the formulas? We have 5 carbons, 6 carbons, 7 carbons, 8 carbons. We have 12 hydrogens, 14 hydrogens, 16 hydrogens, and 18 hydrogens. Yes, of course, we are adding 2 hydrogens for every 1 carbon. And this totally makes sense because carbons make 4 bonds, and as you add carbons to this chain, 2 of the bonds go to carbons and 2 go to hydrogens. This sort of pattern recognition will get easier the more you build. So I really, really encourage you to build these molecules. Octane, of course, is very famous for being a component of gasoline. In a later lesson, we'll talk more specifically about why octane is so important for gasoline, at least in talking about gasoline. I don't think we really need a mnemonic device to remember the names of these molecules because actually the names are pretty logical, right? Pentane sounds like pentagon. That's the 5-carbon chain. Hexane sounds like hexagon, and that's the 6-carbon chain. Heptane, heptagon. Octane, octagon. These molecules are not actually the shapes of octagons and heptagons and hexagons, but the number of carbons reflects the number of sides that these shapes have. By the way, once you've built these molecules, and here you can look at the molecules and check your structures, make sure you put all the hydrogens on. Once you've made these molecules, I would encourage you to play around with them. See if you can create some branches coming off the carbon chain. Can you actually make a ring of carbons? And that actually would look like an octagon, or it would look like a hexagon. So in playing with these models, please go beyond the molecules that I'm showing you here. I want you to improvise, and after the lesson's over, play with these model kits. See how many different kinds of molecules you can make that have 8 carbons in them. See how many kinds of molecules you can make that have 6 carbons in them. You're going to find that there's an almost limitless amount of hydrocarbons that are possible. And that's why carbon is used in biology, because there's so many different ways of connecting carbons because of their 4 bonds. We can create a huge diversity of molecules, which is exactly what you'd need to create a living thing. You need lots of different kinds of structures that can do all kinds of different things.